Hello students. So before we get into today's class, let us recall what we learnt in the previous class. We are learning about sets. So a set is defined as a collection of well-defined objects. So any collection of objects won't become a set. So any collection of object to become a set, it should be well-defined. We saw few examples in the last class. Collection of 5 beautiful flowers. It won't come under a set because it is not well defined. The priority of any person for a flower to be beautiful varies, right? So collection of 5 beautiful flowers, if I say, the list may vary from person to person. So it is not well defined and hence it is not a set. If you take the second example, collection of vowels in English alphabets, it will be always A, E, I, O, U, right? So it is clearly defined and hence this collection will become a set. So we saw what is a set in the previous class. Then we saw how to denote a set. A set is always denoted by capital letters. We will denote it using capital letters, and the objects of set are called as elements. The elements of a set are always distinct and distinguishable. By the word distinct, we mean the elements are not repeated. Every element of a set is unique. And by the word distinguishable, we mean if we state an element of a set, we can easily identify to which set it belongs to, which means every element of a set has its own property. Every set has its own property. So the elements in a set has a unique property. All the elements will have a same kind of property, So all the elements in a set will have a same kind of property. So if I state an element, we can easily say this element belongs to this set, right? Next, we saw a symbol called belongs to. This symbol we use it to say belongs to. As we know already, math is full of symbols, right? Every time we don't want to write this object belongs to the set in words, so we will use this symbol. And if we say it does not belongs to, we will write belongs to symbol by striked off. So we stated few examples here. For example, set A has A, E, I, O, U, and if I want to say the element A belongs to the set A, we will denote it like this, and if we want to say that the element B does not belongs to A, we will denote it by this. Yes, so this is what we saw in our previous class. Hope you understood what is meant by a set and how we can denote it using symbols, right? So before we get into the new topic, I want to state few examples, and I wish to check whether are you clear with the concept of sets or not, right? So here is our first example, a collection of most dangerous animals of the world. So can you say whether it is a set or not? Yes, it is not a set because most dangerous animals of the world. The priority, again, it differs. I may say snake is the first dangerous animal, and few may have a feeling that lion will be the dangerous animal. So if I ask someone to list out the dangerous animals, the list may vary from person to person. Therefore, this statement is not well defined and hence it is not a set. If you see the second example, the collection of all natural numbers less than 1000. Is this a set or not? Yes, obviously this is a set, right? So to whomsoever you state this example, the list will be same. It starts from 1 and it should be less than 1000. So it will have the list like this: 1, 2, 3, etc. Before 1000, so 999. And we know the set is denoted within the flower braces and the elements are separated by commas. Right? Hope you understood the concept of sets now. Okay, now we are going to see methods of representing the sets. So how we can represent a set? There are two types. First one is tabular form or roster form, and the second type is property method or set builder form. There are two methods. I repeat, tabular form or roster form. The other one is property method or set builder form, and most commonly used name here is set builder form. Mostly we will come across set builder form. We won't state it as property method, but when we come to tabular form or roster form, they may use any word to express, right? So from the name itself, we can see tabular form, right? So before getting into this, we will take one common example, the set of all vowels in English alphabet. So now let us see how we can express this in both tabular form and as well as set builder form. Now first, if you take a tabular form, from the name itself we can feel that it just tabulates the values of the statement, right? So in the tabular form we will express it within the flower braces, and the elements are separated by commas. So the set of all vowels in English alphabet. Which are all vowels in English alphabet? A, E, I, O, U. So this is called tabular form or roster form. So from the name itself we can suggest that the method is to express all the values of the statement separated by commas inside the flower braces, right? Now then, how can we express using set builder form? There is a method. So here also you should always start with the flower braces, and we are going to denote it with a variable, say x. For all the examples, we will write it as x as a common variable. So set of all x, such that we will call this oblique sign as such that x is a vowel in English alphabet. So how we can express in set builder form? It is also written within this flower braces, and in general, for whatever example it is, whatever collection it is, we will write it as set of all x, such that we can use a oblique sign or a colon even. So we will write x. In general, we will express it with the variable x, and we will give the explanation for that x. Since it's vowels in English alphabet, we don't have any other explanation, so we have written like this, set of all x such that x is a vowel in English alphabet. If we see few more examples, it will give you a clear idea. But before getting into few more examples, I want to make it clear again. There are two methods of representing set. One is tabular form or roster form, and the other one is property method or set builder form. So in tabular form, what we will do, we will list out the elements of the set clearly by separated by commas. But in set builder form, it will be like partially in words and numbers. It won't be explicitly giving you the values or the elements of the set. It won't explicitly give the elements of the set. It will be indirectly told, and you have to identify and you have to find what are all the elements of that particular set. But when we come across set, it should be denoted within the flower braces only, right? Now let us see few more examples. The set of all even natural numbers. So how we can express this in tabular form now? Tabular form, as I told, it should be expressed within the flower braces, and each and every element of the set should be separated by commas. So it is clearly given even natural numbers. So natural number starts from 1, but since it is given as even natural number, therefore it will start from 2, right? 2, 4, 6, 8, etc. And it denotes all even natural numbers, so we don't know the ending number, right? So this is expressed in tabular form. Now how you will express the same collection, same set in set builder form? We can name this set, say x. How we will express in the set builder form? The set of all, as I told you, we will denote it by some variable x. So the set of all x such that x is equals to 2n, where n belongs to capital N. Hope you can understand. Since it's an even natural number, we have written x is equals to 2n. What is the small n? N belongs to capital N. We know very well capital N denotes the natural numbers. So every x in the set is of this form. Which form? 2n. Why we express this as 2n? Because we are talking about even natural numbers. So only if you multiply the natural number by 2, you will get even natural number. So we have written x is equals to 2n, and we need to give the description for this n even. What is this n? N is a natural number. So in set builder form, how we can express? First we have to write within the flower braces. So how you will read this? Set of all x such that, what is this x? We are giving a description for the element of the set. What is this x? X is equals to 2n, where n belongs to capital N. If you apply values for n repeatedly, we will get 2, 4, 6, 8 and so on. So which is nothing but set of all even natural numbers. Hope you understood. This method is called tabular form, and this is called set builder form. So this is two ways of expressing a set, representing a set. Let us see one more example. The set of all square numbers. Here they have given a name for the set, which is A. So the set of all square numbers. How you will express it in tabular form? I'll write A is equal to, open braces, what are all square numbers? 1, 4, 3 3s are 9, 4 4s are 16, 5 5s are 25. These are all square numbers, right? And again they have not given up to what square number. It goes on. So we will place 3 dot, which means it goes on. This is the way of expressing the given set in the tabular form. Now how you will express the same set in a set builder form? We will write A is equal to the set of all x. And this x is common for every set. You can it is just a denotation, right? So the set of all x such that x is equals to, I can write n square, where n belongs to capital N. Hope you understood. Why we have written n square? Because it is a square number. When we apply the values for natural number repeatedly, for example, if we apply n is equal to 1, we will get 1 square is 1. If we apply n is equal to 2, we will get 2 square as 4. If we apply n is equal to 3, 3 square we will get 9. Likewise, we will get the repeated square numbers. So how you will read this? Set of all x such that x belongs to, this oblique sign you should read it as such that. We can use a oblique sign or a colon even, like this. The set of all x, we can use colon, right? X is equals to n square, where n belongs to capital N. Like this also you can write. Okay, so now what we have seen now, methods of representing sets. There are two ways of representing set. One is tabular form or roster form, other one is property method or set builder form. In the tabular form, don't get confused. From the name itself, we can identify tabulating the values. Tabular form means tabulating or explicitly tabulating the values of the set separated by commas within the flower braces. Whereas the set builder form is, we are giving a outline of the set. We are giving the outline of the set where explicitly we won't list out the elements of the set. It is partially expressed in words. Partially expressed in words and partially in numbers. So how you will read this? The set of all x such that x is a vowel in English alphabet, whatever the description you are giving for that particular element of the set, right? Next, what we are going to see is different types of sets. There are nearly 7 types of sets. First one is finite set, infinite set, null set, singleton set, equivalent set, equal sets. Next one is set of sets. Set of sets is also called as class of sets or family of sets. I repeat, there are totally 7 sets, 7 types of sets. We are now going to learn about types of sets. First one is finite set. From the name itself, you can understand what type of set it could be, right? Finite set means it will have only finite number of elements. As we saw some few examples in the previous topics, like vowels in English alphabets. How many elements does the set has? A, E, I, O, U. It's finite, only 5 elements, right? So if a set has finite number of elements, then it is called a finite set. So when we talk about finite set, there is another a topic called cardinal number of a set. What is meant by cardinal number of a set? The number of elements in the set is called the cardinal number of a set, right? And it is denoted by n of. So if we take the first one for the finite set, as we stated now, take the same vowels example. So A, E, I, O, U. Then this is called a finite set because here it has only 5 elements, right? 1, 2, 3, 4, 5. Only 5 elements. Therefore, it is a finite set. When we talk about finite set, then obviously we can say what is a cardinal number of the set? What is cardinal number of the set? Cardinal number is denoted by n of. N of means number of. So n of A is here 1, 2, 3, 4, 5. So here it is 5. This is called as cardinal number of set. Right? Cardinal number of set is the number of elements of the particular set. Now, second type of set is infinite set. Infinite set means it is not a finite set, which means the number of elements in a set is infinite. And for this also we have seen few examples in the previous topics. For example, set of all even natural numbers, set of all natural numbers. These examples are these are all examples for infinite set where the elements are not finite. It will go on, right? When we talk about infinite set, there we don't have the role of cardinal number because we know it is infinite. So we cannot count how many elements does it has. So there is no role for a cardinal number. So cardinal number is only for the finite sets. It is not for infinite sets. Right. Next we are going to learn about null set. What is meant by null? What is the meaning of null? Null means empty, right? Null means empty. So a set which doesn't have any elements, then it is called as null set, no element, right? So null set means a set doesn't have any element, which is called as null set. So can anyone state an example of null set now? Yes, for infinite set, we can have elements like this: set of all even natural numbers, 2, 4, 6, 8, it goes on. This is finite set and this is infinite set. Next, we are talking about null set. Null set means a set which doesn't have any elements. Example, set of odd numbers divisible by divisible by 2. There are any odd numbers divisible by 2? No, right? So how you will express this set in the tabular form? We can name the set as A and we will express like this: empty braces. If we put empty braces without any element, it is called as null set. It is called as null set. A set without any element is called a null set, empty, right? Example is set of odd numbers divisible by 2. And we can state few more examples. Set of immortal persons. Every person has to die on one day or the other, right? So set of immortal persons is an example for null set, right? Next, what we are going to learn is singleton set. Singleton set means it will have only one element. It will have only one element, single element. Example, set of even prime number. Set of even prime number is an example for singleton set. And what is next? We are going to see about equivalent sets. This equivalent sets and equal sets are defined for two sets. It's a comparison of two sets, whereas finite set, infinite set, null set and singleton set can be named based on a single set which is given for you. But equivalent set and equal sets can be named only after comparing two sets. Okay, if suppose a set A is equal to A, E, I, O, you tell whether this is equivalent set or not. We cannot tell. We cannot state whether it is equivalent or not. So equivalent sets and equal sets can be named only after comparing two sets, right? What is meant by, most of the students will get confused with this equivalent and equal. So when you are learning itself, make it clear. Equivalent means it will have same cardinal number. Two sets are said to be equivalent set if they have same cardinal number. What is meant by cardinal number? The number of elements in the set. If they have same number of elements, then the two sets are said to be equivalent sets. Right? It doesn't matter what type of elements does the set have. A set can have, one set can have a numerical values and another set can have non-numerical values. But if the elements, number of elements are same, then the two sets are said to be equivalent sets. Right? Then when we will call two sets as equal sets, if each element of the set are same. If the two elements have the same elements, then only the two sets are said to be equal sets. But when we will say it as equivalent set, if it has the same cardinal number, that is enough. If they have a same cardinal number, then we will call it as a equivalent set. We will see one example for equivalent set. We will have a set, say A is equals to 1, 2, 3, 4, 5, and we have another set B is equals to A, B, C, D, E. Now what is n of A? N of A is 5 since it has 5 elements. N of A is the cardinal number of A. And what is n of B? N of B is also 5 since it has 5 elements. Now n of A is equals to n of B. Therefore A and B are called as equivalent sets. Hope you understood. It doesn't matter whether it has one or not, whether the elements are same or not. It doesn't matter. If they have the same cardinal number, then the two sets will become equivalent set. Then give an example for equal sets. Now let us see example for equal sets. See, there is a set A which has elements 4, 5, 6, 7, and there is another set B which has elements 5, 6, 4 and 7. Now check the elements of A and B. A has element 4 and B also has element 4. And A has element 5 and B also has an element 5. A has an element 6, B also has an element 6. A has 7 and B also has an element 7. So all the elements of A are same as the elements of B. It doesn't have one more or less, right? All the elements of A is same as elements of B. The order doesn't matter. Order doesn't matter, but the elements are same. Therefore, A and B are called as equal sets. Let us see another example for equal sets. A, the set A is set of letters in the word alloy, and B is the set of letters in the word loyal. Now let us express this set in the tabular form. How we will express? The set A is equal to the letters in the word alloy. So A, comma, L, comma, I didn't write one more L. Why? Because from the definition of the set itself, we have learnt the elements are distinct. The elements of the set are distinct. It is not repeated. So even if you have repeated elements, you should not express it within the representation of the set. So I have written only one L. So A, L, O, Y. These are all the letters in the word alloy which comprises the elements of the set A. Now what will be the elements of set B? Set of letters in the word loyal. Again, the elements in B are L, O, Y, A, and again one more L. We have written already L, so we don't want to repeat. Now let us see element A, L, O, Y, and here also L, O, Y, A. The order changes, but the elements are same. So here we will say the set A is equal to set B. Right? Now can you identify the difference between equivalent set and equal sets? Equivalent set means the cardinal number should be same. If two sets have the same number of elements, then the two sets are said to be equivalent set. But when we will call the two sets as equal sets, if they have the same elements, if they have exactly the same elements, then we will call it as equal sets. Then the last type of set is set of sets, or also called as class of sets or family of sets. What does it mean? It has its elements as set. Its elements itself will be a set. Its elements itself will be a set. For example, see, this is a set. Inside the set, the elements are separated by commas, but every element is a set. So we know a set is expressed within the braces, flower braces, wherein the elements are separated by commas, right? So this type of sets are called as set of sets, or class of sets, or family of sets. We will come across this type of sets while solving the problems, right? So before winding up the class, I wish to recall the different types of sets what we learnt in today's class. So finite set, which has finite number of elements. So when we talk about finite set, and obviously we will have cardinal number. Cardinal number means the number of elements in the set. Next is infinite set, where the number of elements in a set is infinite. Null set means there is no element in a set. Singleton set, it has a single element. Equivalent sets and equal sets are for comparison of two sets. Two sets are said to be equivalent if they have the same cardinal number. Equal sets means if they have same elements. And set of sets or class of sets or family of sets means a set which has another set as an element, then it is called set of sets. So these are the 7 types of sets, right? And what else we learnt in today's class? We learnt about the methods of representing the sets. There are two methods of representing. One is tabular form or roster form. Another one is property method or set builder form. In the tabular form, we will list out the elements within the flower braces separated by commas. And in the set builder form, there is a method to express it, which is partially expressed in words. So how we will read this? The set of all x, and we will use an oblique sign or colon, and we will read it as set of all x such that. We will express a variable for the element of a set, and we will give the description of that variable. What is the description? That x is a vowel in English alphabet. Or when we talk about even natural numbers, we have written like x is equals to 2n, where n is a natural number. Likewise, we can express in set builder form. So before wind up our class, I wish to give few home assignment based on the topics which we learned today. So here I stated 5 questions. So you have to list out or state which type of set it is. Hope you can do it. And next two questions is to express the given question in roster form, and the second one is in set builder form. First one is given in set builder form, you should express in roster form. Second one is it is given in roster form and you need to express it in set builder form. Hope you can do it. If you have any doubts, just contact me. We can discuss the answers in the next class. Thank you.